friends. Now we are discussing on propagation of disturbances, that is pressure waves in a compressed fluid. So now whenever a disturbance is produced in a compressible fluid, so the disturbance is propagated in all the directions. Suppose if you take an example of a stone which is thrown into a water pond at some velocity. So the stone which is thrown into the water pond will be hitting the pond at different points. So we will have the disturbance waves created at different points where the projectile, that is the stone which is hitting the water pond at different points. So we have disturbance waves created. So these disturbance waves which are propagated in all the directions with the velocity of the sound. So that is capital C. So now the velocity of the sound thrown, stone thrown is capital V. So here a stone is taken as the projectile. So velocity of the projectile is V and the velocity of the disturbance wave is C. The nature of propagation of disturbance will depending on the Mach number. So depending on the Mach number, we say that whether the flow is subsonic, sonic flow or supersonic flow. So let us consider a small projectile moving from left to right in a straight line in a stationary fluid. So we are having three cases here. So we'll see one by one. So due to the movement of the projectile, so the disturbance will be created in the fluid. As I said, the example of the stone thrown into a water pond. So this disturbance created will move in all the directions with the velocity capital C. So velocity of the projectile is V and the velocity of this disturbance wave is capital C. Now we are having the three cases. So that is m is less than 1. So that is the case of subsonic flow. That is the Mach number is less than 1. So we'll see how the disturbance waves are having their nature with this case. Now when m is less than 1, so that is the subsonic flow. The Mach number is less than 1. So Mach number is the ratio of V by C. So V by C is less than 1. So that is V is less than C. So let we are taking the values for V and C. Since V is less than C, if we assume V as 1 unit, since C is greater than V. So that is C is taken as 2 units. So now the projectile which is at A. So that is if you take this. So now we take that the projectile is moving from point A and it is moving from left to right and reaching point B. So the origin is A and destination is B. So in between, so we are taking 4 points. That is from A to B. It is covering 4 different points. So each point is covered in a time of 1 second. So if we have 4 points from A to B, so the projectile is taking the time of 4 seconds to move from A to B. So here now the projectile which is at A is moving towards right from left and reaching the point B in 4 seconds. So the distance traveled by the pressure wave. So we know that velocity or the speed is the ratio of distance by time taken. So velocity is distance by time taken. So distance traveled is velocity into time. So time is now 4 seconds and velocity of the pressure wave is C here. So time taken is 4 seconds here, and c we have taken, so that is the velocity of the sound wave as 2 units. So distance traveled by the pressure wave is 4 into 2, so that is 8 units. So once again, so here velocity will be taken as the ratio of distance by time taken. So distance traveled is the product of velocity into time. So velocity is c and the time taken is 4 seconds here. So here we have assumed c, that is velocity of sound wave, as 2 units. So distance traveled is 4 into 2. So that is 8 units. So if you refer this figure, so keeping A as the origin, so that is where we have the disturbance, so that is the radius is taken as 4 into 2, so that is 8 units what we have obtained here. So that is with 8 units as the radius, you draw a circle keeping A as the radius. So that means the projectile is traveling from A to B. So now that is we are taking 4 steps to reach from point A to point B. So that is when the projectile is at A. So that is it is for 4 steps to cover to reach B. So we are drawing a circle having the 8 units as the radius, keeping A as the center. Now, distance traveled by the projectile. So, the projectile, if you take the same example of the stone thrown into the pond. So, now the projectile considered is the stone. So, what is the distance traveled by the stone now? So, that is 4 into v. So that is once again distance traveled is velocity into time. So velocity of the projectile is v. Time taken by the projectile is 4 seconds to reach from A to B. So it is 4 into v. So that is 4 into 1. So that is 4 units. Whereas your pressure wave is covering a distance of 8 units, the projectile is covering a distance of 4 units. Similarly, when the propagation is at the points 3 comma 2 comma 1, so that is 3 different points, that is when the projectile is moving from point 4 to point 3, so that is it is moving one step ahead. So then from 3 to point 2, then from point 2 to point 1, and then from point 1 to the final point B. So that is it is one uh, unit behind my point B, that is the destination. When you take up your point 2, so we say that it is 2 units, just 2 units of distance to be covered to reach my point B. So, for when the projectile is moving from your point 4 to point 3, so now the distance covered will be, so it is 3 into 2. So that is in place of 4 into c, we will have 3 into 2, so that is 6 units. So we'll have 6 units. Similarly, when you take the next point, so we'll have so here 2 into say, so that is 2 into 2, so that is 4 units. Similarly, we'll have 2 units here. So then uh, the distance of your projectiles are 3 comma 2 comma 1 units respectively. This disturbance created at a point A is traveling 8 units in all the directions. So if you refer back the circle, so here the disturbance, so that is here the wave is created. So the disturbance is 8 units in all the directions. So it is a circular one. So that means we have the uniform disturbance in all the directions having the 8 units. Similarly, when the propagation is at the created at point 3. So now it is having the disturbance of 6 units in all the directions. So we are drawing a circle of having radius 6 units and 3 as the center of the circle. We are drawing a circle having the 6 units as radius and 3 as the center. We are drawing a circle. Similarly, when the propagation is created at point 2, we'll have the radius of here. So that is instead of 4 into c, we'll have 2 into c. So that is 2 into 2. So that is 4 units. So we are drawing a circle of 4 units radius. So that is the disturbance is uniform in all the directions with 4 units. Similarly, when the propagation is at point 1, so when it is created at point 1, so the radius is 2. So the disturbance is uniformly created in all the directions with the radius of 2 units. But the corresponding distances of your projectile will be so 3 comma 2 comma 1. So we'll have here. Okay, so at point 4, the distance traveled by the projectile is 4 into v, so that is 4 unit. When it is at point 3, it is 3 into v, so that is 3 into 1, so that is 3 units. When it is at point 2, it is 2 into v, so that is 2 into 1, so that is 2. When it is at point 1, it is 1 into v, so then it is 1 into 1. So that is 1 unit at point 1. So that means here we say that the pressure wave is ahead of your projectile. So your point B is within the circle. So that is here the projectile before the projectile is reaching yeah, the points 3 to 1. Your projectile is first reaching point 3, then the pressure wave first reaches a point 3, then the projectile is reaching point 3. So then the pressure wave is reaching the point 2 first, then the projectile will reach the point 2. That is here your sound wave or the pressure wave is traveling ahead of your projectile. That means before the stone reaches the next point, the next pressure wave is already reached that particular point. So that is the case of m less than 1. So that is a subsonic flow. So then we'll have here m is equal to 1 sonic flow. So that is the pressure wave and the projectiles are moving together. See, that is when the pressure wave reaches point 3. So at the same time my projectile is also reaching point 3. When my pressure wave reaches the point 2, at the same moment my projectile is also reaching the point 2. Similarly, when I come to the destination, when the pressure wave reaches this particular point, the projectile is also reaching this point at the same time. So that means my projectile and pressure waves are moving together. So that is the case of sonic flow. Here the disturbance always travel with the projectile. So V and C are having the same values. V is equal to C. M is the ratio of V by C, that is equal to 1. So disturbance created at A is now in 4 seconds. So that is given as 4 into C. So that is 4 units. So the disturbance wave travels 4 units in all the directions. So that's why we have keeping A as the center and 4 units as the radius, drawn a circle having the 4 units radius. Similarly, when that is the pressure wave reaches my propagation point at 3. So that is the distance traveled will be instead of 4 into c, we'll have 3 into c. So it is 3 into 1. So that is 3 units. So the radius is 3 units, and keeping 3 as center, we are drawing a circle having the radius 3 units, drawing a circle. Similarly, when the propagation is produced at point 2, so that is the distance traveled is now 2 units. So now we'll have here uh, the propagation velocities of the sound wave. So that is so that is 2 into c. So that is 2 into 1. So that is 2 units. Similarly, when you come to the last point, so that is 1. So it is just 1 unit uh, behind my point B, that is the destination point. So taking velocity is equal to distance by time equation. So distance is equal to velocity into time. So now time left is 1 second. Distance traveled is now it is 1 into c. So that is 1 into 1. So that is 1 unit. So keeping 1 as the center and 1 unit radius, drawing a circle here. So all the 4 circles drawn will be having its destination point at B, whereas if you take the other case, so now my destination points, so even though the projectile is traveling from A to B, so the destination points of the projectiles and the destination of the pressure waves are different. So pressure waves are ahead of my projectile. So the projectile destination points are this 4, 3, 2, 1 and B, whereas my projectiles are see here. So the first projectile is having its end point here. So in the first case, so my pressure wave is ahead of my projectile points. But here, the case of m is equal to 1. So here, if you take the example, so here 4 and a, so that is the velocity of the projectile and velocity of the sound wave, so are one and the same. So their destination points are also same. If you take this, the second circle, right? So here velocity of the projectile and velocity of the pressure wave are one and the same. Now we'll have m is greater than 1, so that is supersonic flow. So m is greater than 1 means v by c is also greater than 1. So we'll take v as 1 unit. So v is greater than c. So if v is taken as 1 unit, c will be taken as 0.5 units because c is less than v. So m is equal to v by c. So m will having the value of 2. So the distance traveled by the projectile, so that is in 4 seconds will be, so that is 4 into v. So because the velocity of the projectile is v, so it time is 4 seconds. So distance traveled is velocity into time. Velocity is v and time is 4 seconds. So velocity is taken as 1 unit. So it is 4 into 1. So that is 4 units. Take AB. So that is as the 4 units. Now, so that is the distance traveled by the projectile is 4 seconds, whereas the velocity, that is the disturbance created in 4 seconds is now it is now 4 into c. So where c is taken as 0.5, so that is 4 into 0.5. So that is 2 units. So that is the distance covered by the pressure wave or the disturbance wave is only 2 units. So that's why keeping A as radius, that is the first point, that is the fourth point where the propagation is created. So taking 2 units as the radius, draw a circle having 2 units radius and A as the center. So that is we say that here uh, the that is the projectile is ahead of my propagation wave. See here, my propagation wave is here, whereas my projectile is here. Similarly, if you take the other four circles, so compared to all these four circles, my projectile is just it is beyond these four circles. So these are the disturbance waves or the pressure waves created in the fluid. So my projectile is beyond my propagated waves. Whereas if you take the other two cases, here my projectile and the propagated waves, they are traveling at the same speed, right? When this point B moves ahead, these four circles also moves ahead. That is, when projectile is moving, my propagated waves are also moving at the same speed. But if you take the first case, right? So if B moves, that is the projectile is moving, so my sound waves moves further. So, but sound waves, as you see, so the sound waves are beyond my projectile points. So here in the first case, M is less than 1, my pressure wave or the sound waves are ahead of the projectiles. So, but here projectiles point are beyond my propagated waves. So, waves are left behind, but the projectile is moving ahead. So, now we'll have the take as center and radius 2 units, draw a circle. The sphere of propagation of disturbance always lags behind the projectile. As I said, so here the projectile is moving beyond my propagated waves. So here the velocity of the projectile and velocity of the sound waves are given here at point 4. The projectile is having the uh, units of, that is the distance covered is 4 units, and the distance covered by the sound wave is 2 units. Similarly, at the other 3 points are given now. So now you have 4 different circles. If I draw a tangent to these 4 circles on both sides, the 2 lines which are drawn as the tangents to these 4 circles meet at this end point. So that is the destination point. So forming a cone here. So with the vertex B, the cone formed here will be called as the Mach cone here. A tangent drawn to the different circles representing the propagated spherical waves on both sides will get a cone with the vertex at B called the Mach cone. Now, if we draw a perpendicular here from point 1 on to this tangent, so which is intersecting the tangent at point D. Now we'll have a right angle triangle 1dB here. So this angle, that is 1BD, is called as your Mach angle. So that is given as alpha. So if you take 1b, that is the velocity of the projectile. So if you take this 1b as the velocity of your projectile, as your projectile is ahead of my propagated wave. So 1b is the velocity of the projectile, and this 1d, so that is the diameter of this sound wave. So which is nothing but the velocity of the sound wave. So the the radius represents the velocity of the sound wave. So 1d is nothing but the velocity of the sound wave here. So that is given as c. So projectile's velocity is v, sound wave's velocity is c. So the Mach angle is half of the angle of the Mach cone. So we have sine alpha is equal to opposite side. So that is 1d here. So that is 1d here divided by hypotenuse. So that is 1b. So that is nothing but 1d is nothing but c divided by 1b. So that is v. So it is c by v. So that is nothing but the reciprocal of v by c. So c by v is the reciprocal of v by c, whereas v by c is nothing but by Mach number. So that is m to the power of minus 1 now. Sine alpha is equal to 1 by m. So the relationship between the Mach number and the Mach angle is sine alpha is equal to 1 by m. Thank you.